Ladies and gentlemen, lesson 4, writing products as sums and sums as products. Let's continue into module 3. Please follow with your notes as we begin this lesson. So first, example 1. Let's take a look at parts A through H here. And the first few, what we want to do is we want to write an equivalent expression using the distributive property for the first 4 problems. So first, we already have it in distributive property form, like using the distributive property. Let's rewrite it now in expanded form. Let's distribute through. So first, we have the 2, so we're going to multiply the 2 times x, 2 times 5. We get 2x plus 10. For the next one, we have 3 times the quantity, x plus 4. So we want to distribute 3 times x plus 3 times 4. We would get 3x plus 12. Similar with the next problem, we're going to multiply 6 times x, 6 times 1, get 6x plus 6. For part D, we have 7 times the quantity, x minus 3. So 7 times x minus 7 times 3, which is 7x minus 21. For E through H, what we want to do now is we want to try and factor out a common factor and write the equivalent expression for the last 4 problems in distributive property, as using the distributive property. So between 5x and 30, we want to think of what is a common factor that we can factor out. We can factor out 5 from both terms. If we factor out 5, we're going to have 5 times the quantity x plus 6. For part F, we can factor out an 8 from 8x and from 8. So we pull out an 8 from both, we'll get 8 times the quantity x plus 1. For part G, we have 3x minus 12. We can factor out a 3 from both terms. Pull out a 3, we get 3 times the quantity x minus 4. Here we have 15x and 20. So there's different ways we can look at trying to factor out here. The one term that would probably be the greatest common factor, actually it is the greatest common factor that we can take out from both of these terms, is 5. And we would have 5 times the quantity 3x plus 4. So let's look at the following questions. Let's write an expression that is equivalent to 8x plus 4. And please write this expression in the bottom right corner of the first page of the packet. And then we will discuss this at a later time. For exercise 1, we want to rewrite the expressions as a product of 2 factors. So, meaning, we want this to be similar to using our distributive property. We want to divide both terms by a common factor. 72 and 8 share a factor of 8. So if I just divide both terms by 8, I get the following result. 8 times the quantity, 9t plus 1. Because I divided 72 and 8, both of those, by 8. Once again, for part B, ladies and gents, we have 55a plus 11. We divide both terms by a common factor, so 55 and 11, their common factor is 11. So we divide both of those by 11, we get the following expression. 11 times 5a plus 1. And it's 11 times the quantity, 5a plus 1. So for part C, we can factor out a 36 because we have 36 and 72. 36 is the greatest common factor between those two numbers. So we could rewrite this as 36 times the quantity, z plus 2. For part D, we have 144 and 15. What we can do here, we can divide both terms by 3. So we divide both terms by 3, we get an expression of 3 times the quantity, 48q minus 5. For part E, we have 3r plus 3s. Both of these share a factor of 3. So we can factor out 3 from both. Our expression would now become 3 times the quantity, r plus s. Looking at example 2, let the variables x and y stand for positive integers, and let 2x, 12y, and 8 represent the area of 3 regions in the array. Determine the length and width of each rectangle if the width is the same for each rectangle. So first, we have 2x, we have 12y, and we have 8, and they're asking about the width. Is this width the same? Is it the same for all of them? Yes, it's the same all the way across. So if that width is the same, what number must go here? 2. 2 is this, it's a factor of each one of those terms. So 2 can be pulled out of each one. That means above we would have x, we would have 6y, and we would have 4. So now we could rewrite this expression as a sum and then as a product of 2 factors. This is what it would look like. We originally had 2x plus 12y plus 8 by looking at the diagram, and we could rewrite it using the distributive property, saying 2 times the quantity, x plus 6y plus 4. Looking at exercise 2, we want to write the product and the sum of the expressions being represented in the rectangular array. So here's our array that we're given. What we do is we take 2, we're multiplying it to 12d plus 4e plus 3, or we could write it as 24d plus 8e plus 6. Both of those are correct. Next, we want to factor 48j plus 60k plus 24 by finding the greatest common factor of the terms. Well, first, what we do is we could do the ladder method. We can divide all of the terms by the same factors and find out what is the greatest common factor. Well, first, if I divide 48, 60, and 24, if I divide all of those by 4, I would get the following numbers. I'd get 12, 15, and 6, because 48 divided by 4 is 12, 60 divided by 4 is 5, 24 divided by 4 is 6. Can I go again? Yes, I certainly can. I can divide all 3 of these numbers now by 3. 12 divided by 3, 4, 15 divided by 3, 5, 6 divided by 3, 2. What's really nice about the ladder method is all the numbers that we factored out on the left side, those make up the GCF. So on the left side, we have 4 times 3, which is 12. So the greatest common factor is 12. So we can factor out a 12 from each one of those terms. So 12 times the quantity 4j plus 5k plus 2. Let's continue on. All right, for exercise 3, we want to write each sum as a product of 2 factors, emphasize the importance of the distributive property, and use various equivalent expressions to justify equivalence. So let's take a look at part A. So for part A, both have a common factor of 3, so the 2 factors would be 3 and 2 plus 5. 2 plus 5 is 7, so we have 3 times 7, and this is equivalent to 6 plus 15. Where do we get 6 plus 15? Well, 3 times 2 is 6, 3 times 5 is 15, 6 plus 15 is 21. So all those expressions are equivalent. Let's look at part B. We have 2 plus 5 written 3 times. These are really good problems to get used to writing it as distributive property. We have 3 times that quantity, 2 plus 5. Let's look at part C. Part C, we have 2 times 2 plus 5 plus 2 plus 5 times 2. Now, we have 2 times 2, we can plus 5 times 2 plus 2 plus 5. So we got to be careful. We cannot include the 5 plus 2 just yet within these expressions because that's using addition. We want to be careful not mixing addition with multiplication if it's a separate term. So here, 2 times 2 plus 5 times 2 plus 2 plus 5. So what we can do is we can look at this as, okay, we have 2 times 2 plus 5 times 2. Well, we can pull out a 2 from both of those first sets of terms. We have a 2 here, we have a 2 here. That's being multiplied. So we can factor those out to get 2 times 2 plus 5. Well, here we have another 2 plus 5. So we could rewrite this as 3 times the quantity 2 plus 5. So there's a lot of combining here in this problem. And if you have any questions on this, please do not hesitate to ask. For part D, we have x times 3 plus 5 times 3. Both of these terms share a common factor. They both share a 3. So we can factor out a 3. If we factor out a 3, we have 3 times the quantity x plus 5. For part E, part E is set up purposely to be very similar to part B. We could write this as 3 groups of x plus 5, so 3 times the quantity x plus 5, because we have 3 of them. So we would just simply multiply the quantity of x plus 5 by 3. For part F, we have 2x plus the quantity 5 plus x plus 5 times 2. Ladies and gents, once again, very similar to part C that we're wanting to find some common factors here. So first, if we look at this, we have our 2x, we have our 5 plus x, and then we have our 5 times 2. The 5 times 2 and the 2x, we can factor out a 2. We can factor out a 2 from both of those terms. So we would have 2 times the quantity x plus 5. That's where this comes from. Well, we have another x plus 5 that we didn't touch from the beginning. So another x plus 5, we now have a total of 3. We have 2 plus 1 more x plus 5 with a total of 3. Or we could use the associative property and write it out like so as well. So there's a couple different ways that we can approach this, but we still get the same answer. For part G, here we have a common factor of 3, so we factor out a 3, so we have 3 times the quantity x plus y. For part H, we have 3 x plus y's being added together here. So we have the same thing being added. We can multiply by 3 instead. So 3 times the quantity, x plus y. For part I, we have 2x plus y plus x plus 2y. Once again, we can factor out a 2 from 2x and 2y to have 2 times the quantity, x plus y. Well, we have 2 times x plus y plus x plus y. These quantities can be combined with distributive property to become 3 times the quantity x plus y. Or we could use the associative property and get the same answer, just slightly differently, or in a different order. Let's continue on to example 3. Example 3, a new miniature golf and arcade opened up in town. So for convenient ordering, a play package is available to purchase. It includes 2 rounds of golf and a 20 arcade tokens, plus $3 off the regular price. There is a group of 6 friends purchasing this package. Let G represent the cost of a round of golf and let T represent the cost of a token. Write 2 different expressions that represent the total amount this group spent, and explain how each expression describes a situation in a different way. Well, first, this is an excellent problem to use that cubes method that we discussed from the beginning of the year. We want to eliminate unnecessary information. We want to circle the important information. We want to underline any buzzwords, and we want to box the question. So observe. The first two sentences are going to get wiped out. We're going to circle some very important numbers. We're going to underline some important phrases, and we're going to bracket the questions. So there's two parts that we have to answer. We have to write two different expressions, and then we have to explain how each expression describes the situation in a different way. So first, we could write this as 6 times the quantity 2g plus 20t minus 3. Where'd that come from? Well, each person will pay for 2 rounds of golf, hence 2, and 20 tokens. So 2 times g plus 20t, and then they're going to be discounted $3, so we subtract the $3. And that's for each person. So there's 6 people, 6 is being multiplied to that quantity. So this expression is 6 times the quantity of each friend's cost. So this is the first method that we could write this as. The second, we could write it out by actually distributing through 12 times g plus 120t minus 18. The total cost is equal to 12 games of golf plus 120 tokens minus $18 off the entire bill. So we could look at the entire bill versus each individual friend. Let's take a look at example 4. For example 4, the first question is, what is the opposite of negative 6v plus 1? Well, the opposite is simply taking the negative of that entire quantity. So taking the negative of the entire quantity, what we want to do is we want to distribute. So this next section, using the distributive property, write an equivalent expression for part A. We're going to distribute that negative into the parentheses to both terms. So what happens is, when we distribute that negative through, that's the same as multiplying a negative 1 times negative 6v, and a negative 1 times 1. So if we do that, well, negative 1 times negative 6v is 6v, negative 1 times 1 is negative 1. So our final answer is 6v minus 1. Example 5. So we want to rewrite 5a minus the quantity a minus 3b, and we want to rewrite it in standard form. Then we want to justify each step applying the rules for subtracting and the distributive property. So first, we rewrite. So from subtraction to addition, we have 5a plus negative quantity a plus a negative 3b. Next, we distribute. We're going to write the opposite of a number is same as multiplying by negative 1. So we're multiplying by a negative 1. So we have 5a plus negative 1 times a plus a negative 1 times a negative 3b. Well, to simplify that, 5a plus a negative a plus 3b. Some of these steps can be combined into one. Once you develop and remember these properties, you can combine a lot of these steps into one step. Finally, our final answer, we have 4a plus 3b, and that's combining like terms. Exercise 5. We're going to expand each expression and collect like terms, or combine like terms. So for part A, first thing we want to do, we want to prepare our expression. We then distribute the negative 3 to both terms, and we simplify. When we simplify, we should get negative 6p plus 9q. For part B, same thing. We set up our problem. We're going to distribute a negative 1 to everything inside the parentheses for a plus a negative 1b. We now have negative 1a plus a negative 1a plus 1b.